Now, in our previous lab, we were able to form a tunnel in between R1 and R5. Let's verify that. Show IP, not IP, show MPLS traffic engineering tunnel. There is no tunnel. Okay, there is no tunnel. Show run section router SPF. I'm just checking whether MPLS. It's not there. Is this our topology in our last class?
Yes, sir.
The configuration is missing. Show run section router SPF. Okay, here it is. There. The configuration is there. Let me paste this on router 1. Show MPLS interfaces. Okay. Okay. RCP is not enabled or any of the interface. Here we have it. Right there we don't. This is the command. All right. Now show run interface tunnel 0. Do I have this? Tunnel 1? No. Nothing is there in this router. Everything is gone. At least do I have an IP address? I do have an IP address. I saw MPLS. Okay. So there is no tunnel also. Let's copy and alter it. From R5, show run interface tunnel 0. Destination is file. All the rest of the things are same. Let us check now. Show IP interface brief. Well, the tunnel is up already, which means all our configurations are correct. Now, what I have configured is a tunnel. And not only configured, it is also established. When will it be established? When a path is available for me to reach the tunnel destination 5555 with the constraint. What is the constraint? 1 meg. Show run interface tunnel 0. If there is a path to this destination with 1 meg, whatever the path, use it. That's the meaning of dynamic. I don't have a specific path option. I say you decide. So this path dynamic does not mean the path which is there in the routing table. It means any path that has got this 1 meg bandwidth should be used. If I will reduce the bandwidth on this link G3/0 to simulate that there is no bandwidth, then you will see traffic going via router 3. Right now, if I trace route to 55555, I see it is going straight from 2 to 4. Straight from 2 to 4. I'll go to router 2 and decrease the bandwidth now. Now one more thing I want to show you.
Jay?
Yes.
Jay, I see the loopback IP address 111 and tunnel interface also 111.
What?
On router 1, I see the tunnel interface is also IP address is 111.
Correct, so?
And the loopback 0 also 111.
Yes, that's right. Because we said IP unnumbered loopback 0. Because we said copy the IP address from the loopback interface to the tunnel interface. Let me show you that. You see, we have said on router 5 tunnel interface, use the IP address which is there on the loopback interface. I'm not going to give you the IP address. Use this IP address. That is why when you type show IP interface brief, you see the same IP address on both tunnel and the loopback.
Okay.
That is correct only. It should be like that. Okay, what I was trying to show you is show IP traffic and show traffic engine, show RSVP, show MPLS traffic engineering tunnels. Now what do you see here is the path. This is the route. This is the path it is taking. It is going to router 2 from router 1. See, my address is router 1. It goes from my address to router 2's address. This is the router 2's address of ingress and egress, isn't it? Ingress and egress. See, router 2 has got multiple egress. 10.23 is also router 2's address. But it very clearly says, hey, 10.23 is not. 10.24 is the direction I'm going out from router 2. And then I'm entering on router 4's 2404. And I'm exiting on 10.45, not 10.34, 10.45. And then I go enter into 10.4505 router 5, and then I'm reaching this destination. So it shows this path, it shows very clearly that the packets are going via the gig Ethernet, not via router 3. The only gig Ethernet is between router 2 and 4 here. Now, the committed, the expected bandwidth is 1000 kilobits or 1 meg. That's the expected one. Let's go and decrease it so that this route will not be an eligible one. R2 interface G3/0. Listen carefully. I want to remind you something. Show IP RSVP interface. See, on Gig Ethernet, no doubt we have given 750 meg. There's no doubt. I'm not reducing that. I'm saying, hey, RSVP can use this much amount of bandwidth. I'm not reducing that. See, the path taken earlier was this path. And you see 1 meg allocated, reserved by RSVP because you are pinging from R1 to R5. Now, I'll go to interface G3/0 and say IP bandwidth, bandwidth. In kilobits, I'm going to say only 500 you got in less than 1 meg. I'll also do that on R4. Now, if I take you to router 1, still the path shows that it is going via router 2 to 4 straight, but when I try pinging, it goes via 3. Now, if you go and check the path, it very clearly says it is going via 3. Mine is 1 going to 2, exiting on 223.2 upper path. Entering into router 3, exiting on router 3, entering on router 4, exiting on router 4, entering router 5, going to the destination. So it has taken dynamically another path. So this is the meaning of dynamic. Dynamic is not the path that's shown in the routing table. See, the path that is shown in the routing table is not this. See, in router 2, show IP route for 55555, it says go to router okay, 10.23, because I changed the bandwidth here. I changed the bandwidth. As per the bandwidth, it has calculated the cost. Let us do one thing. We'll fix a cost. What is the cost right now between R2 and R3, It is 10. Now I'm going to set cost here 1. On R2 interface G3/0, IP OSPF cost 1. So OSPF will not use the upper path. You see, go to router 2 and check the route now. It says I should go straight to router 4 in order to reach 555. But the traffic engineering is not taking this path. Let me repeat again on R1. Okay. It follows the OSPF path now. You have gone on from here to 4. Let me also go here and change the bandwidth. The problem is, I need to. This should be more realistic, not manually configured. That's the reason. When the traffic is going in too much, let's see now. First, let me show you what OSPF takes. Okay, OSPF still takes this path. OSPF still takes the below path. What is the path that MPLS takes? Oh no. So MPLS says I go via this path because the bandwidth is available. How is that possible? What? This is very clear. Here it shows I'm going via router 3 to router 4. I'm going via router 3 to router 4. Here the path is nice. There is no problem in this output. When I trace route, it shows like it goes via the gig Ethernet. The tunnel is up, the path is valid, and what is the path? The path is this, going via 3. I appreciate this output, but when I trace route, because there is no real congestion here. I artificially made by changing the cost and this and that. Okay, so that's the reason. But in reality, this is the path. According to R1, it thinks that I'm sending via this path. But router 2 changes the decision. Router 2 says, no. You got a better path. Come via the below path. You don't need to go to router 3. Router 2 says, let's go via the gig Ethernet. Even here it shows very well that to reach 5555, I'm going to send it to router 3. But router 2, when the packet comes, it follows this path. It follows the routing table. Because there is bandwidth available. It can sense it. Even though I artificially made a bandwidth to be only 500 meg.
Daddy, the honeycomb, it started to build its house.
Wow, nice.
In our house.
Don't go close to it. Dynamically, it selects one path, the path that has got that bandwidth available. I reduce the bandwidth by manually configuring 500 meg in this path. So, according to RSVP, this is not the right path to go. It's not. It shouldn't. It is not. According to RSVP, it is not going via this gig Ethernet. That you can see even in the outputs of traffic engineering. But when I trace route, it is not that accurate because it is manually done. It's not real. Okay, this is one. Any question on this?
Jay, yeah, could you show me the tunnel configuration once? So the command tunnel MPLS traffic engineering bandwidth.
100 meg means 100 kilobits, which is 1 meg.
1000 kilobit, which is 1 meg, right?
Correct.
So this is going to allocate 1 meg on the interface or just verify, because we also have a command IP RSVP bandwidth on physical interface.
Hmm.
What does that command do?
You see, this is a tunnel interface is not a physical one, it's a virtual one. The tunnel interface is going to find out a virtual path. Means it is going to provide you a virtual link via one of this path. Either it will be via 224 straight away or 234. The tunnel needs a connection between R1 and R5. So tunnel says whichever the path that has got 1 meg, that path I will use it as the traffic flow path for the traffic flow. And
Okay.
wait, I have not finished. Now this is just only the tunnel side demand. But on the path, every physical link should have some allocation, bandwidth allocation for RSVP. So we went to RSVP, we went to physical interface and say RSVP will be expecting some bandwidth from you. And we did not say how much bandwidth. If you don't say how much bandwidth, then it is going to take 75% of the bandwidth that I showed you in the previous class. On 1 gig link, it was consuming, RCP was taking it for itself 750 meg.
So
Wait,
IP
I have
RSVP
not
band.
finished, please.
No, just to reconfirm.
When you put IP RSVP bandwidth command, that command will take 75% of bandwidth from the total and say RSVP is ready now. We are ready for supporting the tunnel traffic. We have this much of bandwidth, we are ready. We can support up to this much. We can support up to this much. That's the meaning. See, let me show you in that output show IP RSVP interfaces. It says I can support up to this much. I can support up to this much. And you see the reservation it is not doing on this interface because it's not having that 500 meg. It is having only 500 kilobits, in which 75% is this much. In this gig Ethernet, I made it as 500 kilobits. Whereas on the other links, it is 100 meg. In 100 meg, it has taken 75%, and it is keeping it for RSVP. But how much is what the tunnel is using? How much is that we configured on the tunnel? 1 meg. So router 2 says, I'm blocking this 1 meg out of the 75%. See, it's not blocking all the 75%. RSVP is saying I can give you up to 75% of the existing bandwidth if it is available. Here also it is saying I can give my 75%. If I have 1 meg available, I would have given you, but I don't have 1 meg. So I am not giving you. So there is no bandwidth reserved here. Bandwidth is reserved only on the upper path. Only 1 meg you ask, so 1 meg it shows. If you increase it in the tunnel interface, I'll go and increase and show you. $5,000. Okay, now see, immediately 5. So tunnel interface says I want 5 meg, and 5 meg is available in the upper path. And now I go and change it on our 5 also for the return. It's actually it is, see, tunnel has to be configured on either side. Separate, do show run interface tunnel 0. So in one direction I said 5,000. If I don't do in the other direction, don't expect 5,000 of the other direction. You have to explicitly say that. Okay. Now if you go and check it here, look at this. The other direction also 5 meg. Now ask me questions if I have not answered your question.
No, Jay, I got the point. So IP/RSVP bandwidth basically it reserves 75% of the bandwidth.
Yeah, it says we can support up to 75% of bandwidth, but reservation is only 5 meg because 5 meg is what the tunnel needs. Tunnel asks for only 5 meg. Why should I reserve 75%? 75% it is allocated. It says that this much I can support. I can support up to this much. And each flow.
I'm sorry. Could you repeat that again? What?
It says IP/RSVP bandwidth command says up to 75% of bandwidth can be given if RSVP tunnel demands. But right now it demands only 5 meg. I'm reserving 5 meg. I'm blocking only 5 meg. It is not blocking 75%. It is only blocking 5.
5 meg.
Yeah, because 5 meg is what you expect, you configured as a constraint.
Then what is the use of IP/RSVP bandwidth command? Right?
Hello. Listen, please.
Sorry.
Listen, please. How many tunnels right now you have?
1.
Only one. Only one. And how much bandwidth your tunnel constraint demands?
5 meg.
5 meg. What if I have another 10 tunnels? How many meg then I need? 50 meg. Isn't it? 50 meg, right? If I have 10 tunnels.
Okay.
I don't have many customers here.
Mm-hmm.
This is just simple MPLS traffic engineering. What if I have VRFs and I have more customers, more tunnels? Each customer will have different constraint. One will ask for 5 meg, another will ask for 2 meg. They are all going to use RSVP, right? So RSVP says, this much I can support. But currently, only one tunnel and it needs only this much. So RSVP is not blocking all this bandwidth. Still this bandwidth other than 5 meg, remaining 75 meg is available for normal IP routing.
Okay.
I can only support up to 75 meg. That's the meaning. Meaning, if you have 5 meg tunnels, 10 tunnels, I can support. If you have 20 tunnels, no, I can support only 15 tunnels.
Okay.
I can support 15 5 meg. 16th tunnel, I cannot support. My interface don't have that allocation for RSVP.
Okay.
All right, so when I enable RSVP, 75% is allocated, but it is not reserved. No one is blocking that 75%, 75 meg. Only 5 meg is blocked because 5 meg is what currently RSVP needs. But if RSVP needs 75%, you can block the entire 75%.
And also we can tweak this percentage, right?
Yes.
With the
Let me show you.
yeah.
I'm going to tell F01 interface that you can allocate 15 meg. In that 15 meg, each flow should be 5 meg. I'm going to say that. So then it can have 5 meg 3 flows. Interface F0/1 IP RSVP bandwidth. I'm going to say 15 meg. 15
Could you
meg in kilobits is
15,000.
ones, tens, 100,000, 10,000, lakh.
Yeah.
Ones, tens, 100,000. Okay, 15,000. This is 15 meg, and per flow it is only 5 meg. Now you see, changed. By default, it is simply saying 75% and per flow can be up to 75 meg. Here I am saying no, one flow can be
What's the
only.
flow?
Flow is a flow, means from R1 to R5, you ping. That's one flow.
Okay.
And R1 to somewhere else via the same tunnel or different tunnel to the same destination, that's another flow. So each flow can have a 5 meg reservation. When you don't say the maximum is also equal to flow, we can also say maximum is this, but the flow should be this.
Okay.
Right. Any other question from someone? Anyone else? We're going to do explicit tunnel now. Explicit tunnel. For that, I need to go to router 1. Wait, let us go and remove those alterations that I did. See, even though the trace route says it is going via gig Ethernet, but when you trace, even though trace route says I'm going from 2 to 4, but truth is, you see, this has got no allocation. In reality, it's not going like this, but somehow, it shows like this. The truth is, it's going via 2, 3, and 4. Okay, now I'll go and cancel all those bandwidths that I configured, cost that I put. I will remove Right. Now the path will be via the gig Ethernet, not via router 3. I can show you that on R1. Show IP MPLS traffic engineering tunnels. So it goes. Wait a minute. This will change now. It has switched back to this one now. Now let's go to R1. And now you see from 2 it goes to 4, not via 3. Okay. So if I trace route, it goes to 4, and even the traffic engineering output shows the same. Now, I don't like this, assume. My primary path, see now all are using this path because this has got more bandwidth. OSPF is pointing towards this path. Assume that there are too many flows, millions of flows, every flow is going through this path. So what I want to tell is, I want to tell to the tunnel, hey tunnel, use this path only. That's one way. Another way is use this path. This is the preferred path. In case if this is not having that bandwidth that you need, then you may leave it dynamic. Meaning let the RSVP decide by using the OSPF database. So RSVP will check whether this path is available. If this is available, then it will fix this path. But initially it will only look for this path. Priority is only for this path. So this is what I'm trying to do now, because no one is using this path via router 3. This bandwidth is available free always. I want to utilize that. I don't want to go via this congested path because there are many traffic coming from here. There are many. It's a bottleneck. All goes through this one path. There's a huge congestion. I feel like that. So I'm going to send traffic via R3. If that path is not available, then path option 2 will be dynamic. Right now we have path option 1 as dynamic. I'm going to remove it. I'm going to say no to this. Likewise on R5. Okay, what is next? Right now, if you check show IP RSVP, show MPLS traffic engineering tunnel, the tunnel is not up. It's down because there is no path actually. We did not specify the path option. We did not tell what path to remove, what sort of path. Should I use a dynamic path or is there any specific? Nothing is given. Now I'm going to give an explicit path. Listen, I'm on R5. IP explicit path and I'm going to give a number 1. Hey, come on, I don't want this. IP explicit path and I'm going to give a name. We are 3. Name. Hey, come on, what is this? Okay, enable. I could have also given number now. And next is I'm going to say next address is router 4's address I'm going to give. You see, there is 2 modes, strict mode and loose mode. Strict mode is this. You have to give this ingress address and egress address. Again, ingress address and egress address. Ingress address and egress address. And then the destination. Ingress and destination. That is strict mode. Loose mode is you don't need to specify every single address, ingress and egress. You can simply say next address is go to 4.4.4.4. And then from there, next address is go to 3.3.3.3. And then from there, you go to next address is 2.2.2.2. And there you go to 5.5.5. This is what called as loose mode.
So it will be 1 dot
No,
1
it
dot
should
1.
be 1.1.1.
Sorry, 1.1.1.1. Okay. Index 4. Next address 1.1. Okay. This is called loose mode. And that I can go now. Interface tunnel 0. IP explicit path option 1. Come on. Path option 1. And it's an explicit path. And the name of it is VR3. VR3. And then I want to specify loose or strict mode. Okay, it is working. Now you see, I told you it is unidirectional. On R5 I have configured, so tunnel is from R5 to R1 established, but not from R1 to R5. R1 to R5 you have to go and configure. on R1. It's only one direction. Show IP RSV, show MPLS traffic engineering tunnel. And you can see the path exactly as I said. You know, I gave only the router IDs, but it has exactly taken as I expected. Ingress, egress, ingress, egress, ingress, egress. But when I configured in a loose mode. So by taking what I have given, it can figure out these things. And it says I'm going where out to 3 only. Now let's check in on R1. Show IP, show MPLS traffic engineering tunnel. Here the tunnel is not ready yet. I repeatedly tell you again, tunnel is unidirectional. You need to configure. So let us now go and configure an explicit path here. IP explicit path. This time I'm using identifier 1 enable, and then the next address is 2.2.2.2. Next address is 3.3.3.3. Next address is 4.4.4.4. Done. So we have to apply this interface tunnel 0. And earlier I cancelled this. I'm going to now use this. Explicit index or identifier is 1. Enter. So it will check whether the path is available. Yes, it is available, so it is bringing the tunnel up. Now the tunnel is up. Let's go and check whether the reservation of 5 meg is given on all routers. I'll go and check in R3. R3, do you have that 5 meg? Show IP show IP RSVP interface. Yes, it says I have allocated both the direction. Now if you ping or trace route, see, it shows like it goes from 2 to 4 actually. This is because of some buffer thing I can say, but it literally goes where out to 3. Because R2, if you go and see, R2 has got no bandwidth allocated on G3/0. So definitely it is not going where this path, it's going where the upper path. So don't believe this output. Okay. MPLS traffic engineering very clearly says that I'm taking this path, 2 to 3. But when I trace route, somehow the ICMP echo response is coming from gig Ethernet. All right, so this is the explicit path. I can now give path option 2 as dynamic. Right now, if you see here,
Jay,
let me finish this, please.
can you?
1 minute. Right now we have only one path option, that is explicit route. Explicit route. And we don't have path option 2. We are going to add path option 2 and see the output. Yes, what was the question, Ko?
No, the question is to show route to see the path when it's taking from router 2 to router 3.
See, router 2 will take only path via 4, not via 3 because of the high bandwidth. Routing table only shows OSPF route, not RSVP route. Routing table will not show RSVP path, show IP route. Fed. It shows straight via gig Ethernet. The routing table will not show you like that. Routing table is not the control plane for MPLS. Label is what the control plane. Show MPLS forwarding. This is what the important control plane for us. Based on this, only the traffics are pushed. So here it says to reach 55555 via the tunnel. No. 55555 gig Ethernet, right? So let me clear this. Clear MPLS forwarding. Clear MPLS LDP. So now it's
Clear MPLS IP?
no. I'm not clearing IP. I'm clearing MPLS labels. 'It is all because of this buffer. It goes to 4. Here it says it is using this path, but RSVP is saying to go via this path. Five 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 five. Why is it going this F00? Funny, there is something misconfigured. This is getting incremented. This is not in use. Means label switching is happening only via this path. Okay, the counter is now closed. Let me now try to go and again the same path it takes. But because there is no real congestion, it may take this path. But if there is real congestion, this is not possible. This is not possible for 5 meg to go through this when there is fully congested. So automatically it would have gone this way. as per MPLS traffic engineering. See, show MPLS traffic engineering tunnel. Here also it clearly says you should go to 3. You should go to 3. You should go via F01 and you should use label number 24. But unfortunately, the reality on the interface says there is no congestion here, so the packets are pushed opposed to the explicit path. Okay,
Jay, one question. We have now given the explicit path, right?
we have given the explicit
Uh,
path. What do you say? We
yeah,
have given, no?
yeah. So let's say uh,
Hmm.
the path is not available anymore.
Okay, so
Does it take the alternate path, or
no, it
the
won't
tunnel
take
will go
because
down?
we don't have path option 2 dynamic mentioned.
Okay.
That is what I'm trying to do now. So instead of getting dropped, if I want the fallback, I'll say path option 2 dynamic. So if path option 1 is not available, then it will dynamically decide. I should also do this on R2, sorry, R5. That's it. Now let us verify show MPLS traffic engineering tunnels. Here you see currently it is using path option 1, but 2 is also configured. Currently path option 1 is active. Now let us make that path option 1 invalid and see what happens. R3, I'm going to shut down this interface. Done. Now let us go and check here what path option is active. Okay, you see, right now path option 2 is on the top because path option 1 is explicit, which is not currently available. You got this? Show even here you can see the path option 2 is active because 1 is down now. Let me bring it up. After I bring it up, if I say wait a minute, it still says path option 2 is active. We need to wait. Clear MPLS traffic engineering tunnel. What happened to path option 1? Path option 1 explicit is not active. This is path option 2 dynamic. I brought it up, right? Interface 3. 00 is up. Show MPLS traffic engineering tunnels. Show IP RSVP with interfaces. Oh, so we have to initiate. Ping 55555 with a source. Oh, no. Still, it's not coming via router 3. So because the path currently which it is having is path 2, the dynamic path which it is currently using is having enough bandwidth, it is not switching over. We need to enable some preemption for this. We need to do some preemption so that it will check the explicit path. Only if explicit path available not available, it should use this. Whenever this comes up, it should fall back to this. It's not falling back because it is happy with this path. It's not falling back. In case if I shut down this path, that it will fall back to router 3. I'm going to shut down R2's interface G3/0 shut down. Now if you go to router 3 and see, earlier it was 00, no allocation, but now you will see 5 meg allocated. It falls back. Yeah. So go to router 1 now, trace route, ping, trace, and show MPLS traffic engineering tunnels. It says path 1 is the active one, and this is the path taken. Record route is one of the important option. Let me show. Interface tunnel 0. Traffic engineer. MPLS traffic engineering tunnels. Record route. No. Traffic tunnel MPLS traffic engineering. Record route. It will copy the route that is actually taken. So now, after saying this, let's see the output. I'll say record the route. Right now we have not pinged. Let's ping again. Now see the output. It shows the route. The recorded route goes to router 3. After 2 and 4 and 5, it records the route. Now let me bring that gig Ethernet on R2 up. I am bringing that gig Ethernet up. And now I want to trace the route and see what the record route says. It says I'm going via 2, 4 and 5. Even though my explicit path is via 3, even though explicit path is via 3, which is active, even the recorded route very clearly says it goes via 3. But surprisingly, the ICMP only shows me that as if it is going via 2 to 4. It is because, it's no real congestion there. Okay, so next is what? The other things we'll see. There are a few other optional things, and then we'll get into VRFs, more customers, more tunnels. We'll stop here.